Hi guys, so in today's video we are going to be talking about Hess's law. We're going to talk about Hess's law under thermochemistry. So I have some written examples. To download the question, just check the description below this video. You download the question from there. So they gave us this question. They gave us this equation. 2H2O. 2H2O given 2H2 plus O2 with the enthalpy plus 572. Enthalpy of plus 572. And O2 given 2O with oxygen. Then they asked us to find the enthalpy of this equation, H2 plus O giving H2O. So we find the enthalpy. So according to Hess's law, if you are given a question like this, we are going to reform these two equations in a way that is going to resemble this one. We modify these two equations in a way that is going to resemble this one. Then we add the enthalpy together. So to do this is easy. You just look at this equation. This is the equation we are looking at. This is the one we are following. So we have H2O here. We have H2O here. So we just look at the equation that has H2, and that's equation 1. Equation 1 has H2O. So, and H2 is in the reactant side here, but in the product side here. But we want this H2 to be in the reactant side. So what do? We reverse the equation. And you can see here that H2 is one molecule, but here is 2 molecules. So we divide through by 2. So we reverse this equation 1 and divide through by 2. So after reversing it, we get equation 1, we get H2 plus O2, half O2, because divided by 2, giving H2O. Then the enthalpy, since we divided everything by 2, the enthalpy 2, we divide it by 2. Since we divided all the side of the equation by 2, the enthalpy 2 divided by 2. So that will be 572 divided by 2. 572 divided by 2. That's 286. But mind you, we reverse the equation. So because we reverse the equation, the sign of the enthalpy will change. So that will be minus 286. 286 kilojoule. Minus 286 kilojoule. But I said it in my last video that when you reverse the equation, the sign of the enthalpy will change. And if you multiply by any factor or you divide by any factor, you also have to divide the enthalpy by that factor. So here, because you reverse the equation, the sign changed to minus, and because you divided all through by 2, the sign changed to we also divided the enthalpy by 2. And why do you divide by 2? Because what we are looking for is H2, not 2H2. So we have to divide this one by 2. And if you divide this one by 2, you have to divide everything else by 2. So that's minus 286. So here we have H2 plus O. H2 plus O. If you also look at this equation, let's consider equation 2. O is here. O is here. O is not here. O is here, but O is in the product side. But we need it to be in the reactant side. So what do? You also reverse the equation. And this one is 2O, not O. So we have to divide all through by 2. So when we reverse the equation 2, we get O giving half O2. Why the change in H? We also have to divide the change in H, the enthalpy. We also have to divide by 2 because we are dividing all through by 2. And because we reversed it, the sign to will change. So that will be minus, that was 495 divided by 2. That will be minus 247, minus 247.5. minus 247.5 kilojoule, as you can see. So this is not the final answer. The final answer, for us to get everything, we now need to add the equation together. So that one will show maybe you are correct or not. So when you add the equation together, everything must cancel in a way that if you cancel till you get this equation back. Like these two things, these two equations, this modified equation must cancel in a way that you get this two back. So let me show you what I'm talking about. Yeah. Look at here, we have half O2 here. We also have half O2 here. So that's this one will cancel this one. Because this one is the reactant side and this one is the product side. So when this has cancelled this, the overall reaction will be, can you see it here? The overall reaction will be H2 plus O. We write everything reactant side, H2 plus O, giving H2, because we cancel this one. So this is giving H2. You can see that our final equation resembles the one that they said we should get. So if your final equation is exactly like this one, then you are correct. So what next? We just add the two enthalpy together. To get the enthalpy, just add the two enthalpy. That will be minus 286 minus 247.5, and that will give you minus 533.5 kilojoule. So that's just it. Yeah, so let's take a look at this question. They said N2 plus 3H2 gives 2 molecules of ammonia. When the change in H, the enthalpy is negative 92 kilojoule, and H2 gives hydrogen plus half oxygen. When the enthalpy is positive 286 kilojoule. Then they said you should find the enthalpy of this reaction. So the first thing we need to do is to modify these two equations in a way that it look like the overall equation, because this is one we are driving at. So our modification must resemble this one. It must be exactly like this one after cancelling everything out. Then we add the enthalpy. So the first thing to do here is, let's take a look at ammonia. Ammonia is here, in the reactant side of this our standard equation. Let's call it standard equation. But in the equation here, in equation 1 and 2, our ammonia is here in the product side. And since it is only in equation 1, what we do is that we reverse the equation. We reverse the equation of equation 1. We reverse equation 1 to have ammonia in the reactant side. Because ammonia is in the reactant side here, but here is in the product side. So we have to reverse this equation so ammonia can be the reactant side. And here we have 4NH3, but here is 2NH3. So we have to times everything by 2. So you can have 4NH3. So we have to times equation by 2. Equation 1 by 2 and reverse it. So what we have is, when we reverse it, we have, let's say 2NH3 giving N2 plus 3H2. But that's not all. We need to times 2. So when you times everything times 2, here you get 4NH3. You get 2 times 2 is 4. 2 times 1, that's 2. That's 2NH2. And 2 times 3 is 6. That's 6H2. That's 6H2. Don't forget, since we've reversed it, in the enthalpy, the sign will change to positive. And since we times by 2, that will now be 92 times 2. So that will be positive 92 times 2, that's 184. That's positive 184 kilojoule. So we are done with ammonia. What we do next is, let's look at oxygen. Yes, let's look at oxygen. Oxygen is also in the reactant side, but in equation 2, oxygen is in the product side. Now let me give you one hint. When you see hydrogen, like even you see an element that is present in the two equations, don't use that element because it's going to give you a lot of problem. Just use the one that is present in one equation and is not present in the other equation, so to make it easier. So oxygen is present here, but it's not present here. But in the standard equation, oxygen is in the reactant side, while here is in the product side. So what we have to do is we reverse it. But now we have 3O2. we have 3 molecules of oxygen here, but here is half O2. So what are we going to multiply by half to give us 3? That will be 6, because 6 times half is 3. So we have to multiply all this equation by 6 and reverse it. So when we reverse it and multiply it, what we are going to get is, here will be 3O2 plus 6H2. Now we are multiplying by 6. Then it give us 6 here. We have 6H2O. And don't forget, since we've reversed it, the enthalpy too will change. That will be minus, that's negative, then 286 times 6. Since we multiplied everything by 6, that's 286 times 6. That's 1716. Negative 1716 kilojoules. Now let's add our equation together. So when we add our equation together, we find out that hydrogen here, 6 hydrogen is here, 6 hydrogen is here. It's going to cancel out because it's in the reactant side here, in the product side here. So let's cancel it out. It's cancelled out like that. Then there's nothing else to cancel. So let's add together. That's 4NH3 plus 3O2. It will give you 2N2 plus 6H2. You can see that our final equation, it resembles this one that they gave us in the question. So if it's exactly the same, then you're on the right path. So what's next? You ask for the change in H. Then the change in H, just add this together. 184 plus minus 1716. That's negative 1532. Negative 1532. So that's the answer. But let me give you, since for your test or exam, it's going to be OBJ. So this one is because I'm explaining it, that's why I'm writing this full step. For your test or exam, you don't need to write all these full things. What you just need to do is, you don't even need to be adding all this equation. What you just need to do is, if you see that this one is having 6, I want to get this one, just reverse the equation, multiply it. Is this value they are going to ask in the exam? They'll say find enthalpy. So is this value to find? So you don't need to be doing all this equation stuff. Just know how to manipulate with the value and get your answer. So when you reverse it, just know that the value it will change in sign, and when you multiply it with also the enthalpy. So that's how to get your answer fast when you are dealing with OBJ. Because your test is OBJ, you cannot be writing all these long equations. Yeah, so this question is from the slide. It's directly from the slide. It says to find the enthalpy for this thermochemical equation, and they give us these 3 equations. So I want to show you the fastest way to solve this instead of just writing equations, summing it up, and wasting your time. And when time is running with test or exam. So the first thing we need to do is look at this equation, look at the elements in this equation, look for them here, and just manipulate. So let's start. So we have carbon here. Carbon is in the reactant side. In all these 3 equations, it's equation A, we have carbon. But carbon is 2 here, carbon is 1 here. So what do? We multiply this one times 2. But since in the reactant, we don't need to reverse. So that's change in H. Change in H is equal to, since we multiply this one by 2, that's minus 393.5 times 2. That's minus 787. Minus 787. Then we've done for carbon. For hydrogen, hydrogen is in the reactant side. Here, hydrogen is also in the reactant side. And 1 mole. So we leave it like that. That's change in H. And since in the reactants, we don't need to reverse again. So change in H, just write it like that, minus 285.8. Why the last one? For C2H2. For C2H2, we have C2, but here C2H2 is in the product side. Here C2H2 is in the reactant side. So what do? We reverse this equation. And here is 1 mole, here is 2 mole. So after reversing this equation, we now divide by 2. So when we reverse this equation, we get plus 2598.8. But we are dividing by 2, that's 2598.8 divided by 2. That's plus 1299.4. So after that, just add all your enthalpy. That's minus 787 minus 285.8 plus 1299.4. That will give you 226.6. So that's how to do it. That's how to do it in the fastest way. Since we know that if you divide here or we multiply here or we reverse it, you are still going to do it here. So instead of doing it to the equation, just do it directly to the enthalpy and just add it. And that's like, because in the exam they're not going to ask for the overall equation, they just ask you for the enthalpy, because the overall equation is still this one. So they just ask you for the enthalpy straight. So you just do it and fast about